I have this is the capillary and 2n is closed, so I consider this is the closed system because it is the closed system. So I have the molar flux is 0, and molar flux, the overall molar flux equals to concentration molar concentration times average molar average velocity equals 0, and the concentration always greater than 0 or like different from 0. So the velocity, the average, the mass, the molar average velocity is 0. From here, I know that I have a part ratio, the mole ratio of water times velocity of water plus the ratio of DO2 times velocity of DO2 equals 0. So I have I come with this equation, and I have a pure concentration of pure water is 55,555 mole per meter cube, and DO2 is 55,500 mole per meter cube, and the J, like the diffusion, the molar diffusion flux maximum at 0.1 second, it happens in the surface, like interaction surface between two components. So it happens at z equals to 5. So I have is similar. I can call it like dz, and the maximum, like the concentration of H2O at 5 centimeters or in the middle equals to 1/2 of the concentration of pure water, because this area, and at the surface we have both H2O and D2O. So but like in the left side we only have H2O. So the concentration of H2O here will be 1/2 of the concentration of H2O in the left side, as well as the concentration of D2O in the surface equals to 1/2 of the concentration of D2O in the right side. One reason is that I have 1 mole of H2O go this way. I have the other, also have 1 mole of D2O go this way. So that's why the velocity, or like the mass velocity, the molar velocity of D2O and H2O equals, but just in different direction. So from this equation we have this V equals to each other, and that's why the X also equals to each other. And at this location, X D2O plus X H2O equals 1, so the X is 1/2. That's why the concentration of H2O and D2O in the middle equals to 1/2 of the pure concentration. From here we have I can calculate the concentration of the molar concentration of H2O and D2O is this number, and the J max here is because the J max is positive, so this is the J max, the J of H2O, since H2O go this way, and I have J max is the diffusion flux of H2O equals to concentration of H2O times velocity of H2O. This is the J max. The J of H2O equals to concentration of H2O times velocity of H2O minus the molar average velocity, but we know that average velocity is 0, so we only have this equation, and we end up with the velocity of H2O and D2O is 10 to the negative 4 meter per second, but it's just in different directions. So like we have H2O is plus and D2O is minus, is negative. So we have the overall mass concentration is NH2O plus D2O. From here I have this equation, and I just put the number in and end up with the result is roughly negative 0.0055 kilogram per meter squared. I have driving force equals to dy over dz. It equals to diffusion flux of I over negative total concentration times coefficient. So I have the driving force of H2O at the maximum driving force of H2O equals to diffusion flux of the maximum diffusion flux of H2O divided by negative total concentration times coefficient. So I put the numbers in, and the total concentration equals to, at this point, is the middle, or at z equals 5. So in that point, the concentration equals to the total concentration equals to concentration of H2O, which is this, and concentration of D2O is this. As I calculated in the question 1, the coefficient is 10 to the negative 9. So I have this. So the maximum driving force equals to negative 50,000 65 meter per second. The slope is we have the concentration, mass and molar concentration will be pretty much similar curve, because their concentration. So in the position 1 to 5, around 5, it will be the concentration of H2O is the highest, and the concentration of D2O is 0, because on the left hand side, they don't have it. There's not any D2O in the from 1 to 5. However, from 5 to 10, the concentration of D2O is the highest, and the concentration of H2O is 0. That's why they have the mass concentration and molar concentration is pretty much similar, but the mass concentration of D2O is higher than the mass concentration of D2O, although like the molar concentration is pretty much at the same, is around like 55,000 or like mole per meter cube, or like 55.55 mole per liter. In the final, we have the concentration of both components are equals and uniform in the whole system. So it's a straight line, the horizontal line, and in the intermediate of the process, they have the the concentration is like reduced. So however, the concentration of in the middle is still similar to the the final one. So that's why like they have the same, like if we go from here to here is like the same, but the concentration at two ends like start reducing. So that's why they have the curve is like going down, and the diffusion flux of two equations. In the beginning, at two ends they don't have any diffusion flux because the velocity is 0 in two ends, because they don't have any interaction to each other. So they only have the interaction at z equals 5. So at z equals 5, it's the maximum. And also in the constant and interaction curve, like interaction surface, starts spreading out. So like that's why the velocity is starting spreading out like into ends. It starts sooner than in the initial, in the closer to two ends than initial, and the maximum diffusion flux is reducing because of the because the velocity reducing, so because of the decrease in velocity in the beginning, like in the middle of our system. So like that's why it's the maximum is lower than in the beginning, and at the end the velocity is in the whole tube is 0 because the concentration is of both components are equals. So like they don't have an uniform, so especially like, and so like that's why the velocity is 0 in the whole tube, and the velocity, like the diffusion flux relate to mass flux, and because the molar mass of D2O is bigger than the molar mass of H2O, so that's why it goes downward, and it goes from 0 to negative, because D2O go to the negative side to the left, from right to left, so it's negative, so like that's why it's negative side. And the similar idea with the diffusion flux, it starts like sooner, the velocity starts sooner, so that's why the curve going down sooner, like in the closer to two ends than in the beginning, and the peak is like closer to 0 than in the beginning, and also like in the end, time is infinity. The velocity is 0 because the concentration of two components are equals and uniform, and not equals, but like they're uniform throughout the tube. So that's why they don't have the atoms don't move anymore. And this is our whole graph.